Hello, welcome to my presentation. Today I will be talking about bioplastic, as well as petroleum-based plastic. Hope you enjoyed my presentation. All right, so first off, we're going to be talking about normal plastic. Normal plastic is produced using large amounts of petroleum and oil, which causes it not to degrade in the environment for thousands of years, causing the environment to clog up. Plastics belong to a group of molecules called polymers, which are large molecules made of repeating units called monomers. Most plastics contain between 500 to 20,000 or more repeating units. Plastics can be produced by bonding together monomers in a reaction called polymerization. For example, a plastic called polyethylene, which is commonly used in grocery bags and packaging, is formed by adding together molecules of ethylene. Now, bioplastics. Well, bioplastics are created in a method that is environmentally benign and will degrade over time. Oxo Biodegradable bioplastics and hydrobiodegradable plastics are the two most popular forms of bioplastics. They are materials that come from renewable sources. Two common types of bioplastics are listed above. They are both created to resolve the ongoing environmental issues caused by plastics. They are also degradable, meaning that they could break down in the environment. Materials like starches, cellulose, soy protein, vegetable oils are all used to make plastic by crops and bacteria. We're going to talk about the first type of biodegradable bioplastic, which is hydrobiodegradable plastics. And these type of plastics include a lot of starch and can be manufactured with some oil-based materials. In grocery stores, hydrobiodegradable bioplastics can be utilized to make plastic bags. Hydrobiodegradable bioplastic degrade faster than the next form of bioplastic, which is oxo biodegradable bioplastic. And the reaction that causes them to break down is hydrolysis, which occurs when the product comes into contact with water. The plastic will decay without leaving any trace of petroleum, making it incredibly environmentally friendly. Biodegradable bioplastics have the advantage of being absorbed by the environment faster than other polymers. They don't produce any greenhouse gases this way. Now, oxo biodegradable bioplastic. These type of bioplastics are composed of petroleum-based plastics, which are synthetic polymers. They're widely used as grocery bags too. Oxo biodegradable plastics are conventional plastics like PE mixed with additives or metal salts to imitate biodegradation. Under sunlight or oxidizing conditions, this plastic quickly fragments into smaller pieces of microplastics. Oxo biodegradable is strictly nothing to do with living organisms involved in its degradation, so therefore it's not really a biodegradable product. The production of oxo biodegradable plastic emits carbon dioxide gas while degrading, which causes carbon dioxide gas to be released into the atmosphere, which is harmful to the environment. Besides emitting CO2, it can also emit methane in certain cases into the landfill, which is even more dangerous and can cause a lot more problems to people. Now for the process. Well, plastics are composed of long molecules of carbon and hydrogen. When additives are added into the plastics, it will break down these long molecules in the presence of oxygen, UV light, and mechanical stress. These oxidized plastics will degrade and break down into smaller pieces. At a certain point, these fragmented molecules will start to biodegrade in the presence of microorganisms and turn into carbon dioxide, water, and biomass, eventually used in photosynthesis. And that is explained right in the picture that is displayed. Now we're going to be talking about some more production in bioplastics. First off, bioplastics are made by converting the sugar present in plants into plastic. In other words, plastics are made by polymerization, like I said earlier. And polymerization is any chemical reaction that results in the form of a very big chain-like or network molecule called a polymer, as you can see in the picture, from comparatively tiny molecules called monomers. The monomer molecules could be identical or could represent 2, 3, or even more distinct compounds. Here's an example of a biodegradable bioplastic polymer, and it's called PLA. PLA stands for polylactic acid, and it's a synthetic polymer derived from fermented plants. Comes from corn or sugar cane. The monomers are called lactides, which later polymerize to PLA. When it burns, it does not make toxic fumes, which is a good thing, and it's broken down to carbon dioxide and water. The PLA is produced by a direct condensation, while the condensation water is continuously removed by the azeotropic distillation. The process includes reduction of distillation pressure of La for 2 to 3 hours at 130 degrees Celsius, and the majority of the condensation water is removed. Catalyst is added with the diphenyl ester. PCl. PCl is also a synthetic polyester that is partially crystalline, having a low temperature of 60 degrees, which is the melting temperature, and a glass transition temperature of negative 60 degrees. It is made by ring opening polymerization of caproactone. PCl is degraded by hydrolysis of its ester linkages in physiological conditions, such as in the human body, and has therefore received a great deal of attention for use as an implantable biomaterial. In particular, it is especially interesting for the preparation of long-term implantable devices. A variety of drugs have been encapsulated within PCl beads for controlled release and targeting drug delivery. PCl is often mixed with starch to maintain and obtain a good biodegradable material at a low price. Now here is a petroleum-based plastic polymer. It's called PVC, and PVC is basically produced by polymerization of vinyl chloride monomer, which is VCM. The main polymerization methods include suspension, emulsion, and bulk methods. About 80% of production involves suspension polymerization. PVC is the most environmentally damaging plastic. The PVC life cycle, its production, use, and disposable results in the release of toxic chlorine-based chemicals are very dangerous. These toxins are building up in the water, air, food, and food chain. So now to conclude my project and presentation, when comparing hydrobiodegradable and oxo-biodegradable bioplastics, hydrobiodegradable plastics are more suitable to replace petroleum-based plastics because of the ability to properly and completely degrade more faster without releasing toxic fumes like oxo-biodegradable. They can also be used as fertilizer for the earth, which is also a good thing for the environment. Anyways, this is the end of my short presentation. Hope you enjoyed it and have a good one.